Good evening. Thank you very much for joining me today, this wonderful rainy Phoenix evening. Thank you for braving the streets. Today we're going to be talking about building a server then and now. Basically, kind of looking at how we used to do things, all bare metal, and where we're kind of going nowadays, which is just, the whale, a Docker container, something wonderful. So Wikipedia says a server is a computer program or device that provides functionality for the other programs or devices called clients. I'm going to expand a little bit on that tonight, because as far as being also programs and devices, it can be us directly. As the program that I'm going to be showing you today, it's basically just something that's monitoring something that's important to me, very asinine to probably everyone else, and going to tell me when I need to do some things. It is my Clash of Clans notifier. Basically, I did this because, I play the game and a little bit too much of a problem. And I realized that I wasn't keeping good track of my resources and everything else I needed to keep track of with it. And so basically, I then created this, my database. There is no API for this that I'm aware of. There are no, I didn't actually go look for any files. That would have been the smart thing to do, to see if the phone stores any of this information that I could just scan. No, I just manually enter in fact, we can see right down here, if I get something new, like I upgrade my clan castle, I can then say, oh, hey, look at that. I have a new air bomb, and I can just add that in. Anyway, this is all manual. Fortunately, I've gotten smarter that when, I've already upgraded a Seeking Air Mine to a level 3, so I have this upgrade to next level button. It definitely helps quite a bit. But other than that, sometimes I just need to update it by hand. So this is lazy enough as it is, but I don't look at this page all the time. As you can see, I have 1 day and 13 hours before my Canon upgrades. And so I thought, well, why not have a reminding buddy, my notifier? So I said, I basically sat down and I wrote this guy. I basically wrote a method I call run it, and we'll get into why later. But it basically looks at, a little SQLite database for this presentation, just to make life simpler. I connect to it, I get a query going. Upgradable to means that I'm in the process of upgrading it. And I create a Twilio client, just in case I do need to send myself an SMS message. So here's basically what kind of makes the server. It's the while one loop. It basically means that it's going to run forever. It's never going to stop until I stop it, until it dies, until it eats all the memory out of the machine, you name it, but it will keep going. There's nothing going to stop this loop. Basically, do some logging. We'll get into that shortly. I execute my query, and then I just kind of go through here. I get the row. I checked how much time is left for what I got, for what is upgrading. Basically, I check the duration against the current sleep duration, which I've artificially set to 60. But if it's my first pass, I just set it immediately. If I have a duration that's lower than that, then I set it to that. Basically, the idea is that when I'm done with everything, then I want the program to sleep. And I want it to sleep smartly. I don't want it to execute again until the next thing's ready for upgrading, because there's really no reason for it to go. So if it does all this, and it figures out how long it's supposed to sleep, and that the duration that I'm currently looking at is less than my alert threshold, it will then add to this message. But basically, it'll say, hey, your Canon is about done. And then down here, if I have a message, it will then send me that through the Twilio client, which actually works fairly well. So this is the server that I want to run. And what do I need to consider when running the server? The server, at least the way things were, it ran on a physical server, or maybe a VM, but either way, it coexisted with other users, with other people's data, and with other servers and other processes. So the biggest key point was we needed to be a good neighbor. This being a good neighbor comes through basically how a server needs to be stood up and run. And that's where this checklist comes in. And again, if you want to deep dive into these specific topics, I would refer you back to a demonstration I gave back called Becoming a Daemon. For this demonstration, I will be kind of zipping right over it, or going quicker over it. But basically, the first thing is we check if there's a PID file. Basically, is there a file out there with my process number? Am I already running? This is the nice way so that I don't run my server on top of itself. so that I don't, if I have 5 times the same server running, all of a sudden I get 5 text messages. It's a little bit annoying. Then I open up a connection to that process file ID. And we do that here because if we can't do it because it's out of space or can't write to the OS, we want to die immediately. We don't want to go through a whole bunch of other hoops and then potentially not even see this message. Then we run the process of becoming a daemon, and we'll get into that shortly. And then we actually create the process ID file. Now that we've become a daemon, now we can say, okay, now it's time to go out and tell the world that you're running. We initialize logging because obviously we now need to have some way of communicating to the outside world what's happening to us in case something goes wrong. We set privileges for our process, and then we actually run the process. All of this just to get to running the process. This is all about being the good steward, the good friend. So basically, and here's that entire block, in fact. So becoming a daemon, that's where we're going to take a look at. Basically, we fork ourselves. Forking basically means that the program creates a direct copy of itself. It shares all open file handles. Any type of signaling will be shared. But other than that, it will be 2 separate processes. The parent will get an ID for the variable, will get the child ID. The child will not. So basically, we say we exit out of here if we have an ID. Basically, we're the parent. We've done our due diligence. We've spawned the child. We are now ready to wait. And again, you can refer to the earlier talk on exactly what that all means. This little bit of magic sets you as the lead session ID, meaning that any other sessions coming from you, happening from this process will spawn from your session. We close out the standard in and standard out and standard error, basically making sure that we are no longer talking. We set, so basically this makes it so if we create new files, they will only be created with a certain position. And these 2 lines are kind of the important, well, they're all important. These are very important. These are about isolating you. First off, we want to get rid of all of the environment. We want to get rid of any information about where we exist. Now, I need to keep some information in here about like my Twilio key, my phone number, because I don't want those to appear up in the code. And this is the lazy way of doing them, of just injecting them into the environment. But so if you were writing this yourself, you wouldn't have this part. You would simply delete out your entire environment. If you needed something in there like a Perl 5 lib or other type of environmental variables, you would set them specifically here. And then you would change the root to this variable home directory. Home directory, you could have you would probably have a very specific place for this. For this purpose, it was just basically the directory that the script was executed in. And what this does is it means that, okay, now / or the root directory is that subdirectory. If someone were to be able to compromise my server and land at the root, they're actually inside of a subdirectory of my system, which they cannot see. And then we set up a signal for reaping the children, which the parent will see, and the parent will dutifully wait for all of the children to finish before it exits, because if that happens, then we have zombie processes, and that's a whole different topic, which is also fun. So basically, all of these steps, oh, I'm sorry, no, there's more to that. So yeah, all these steps, and wait, there's more. So we initiate the logging. I'm using log for Perl. I like this type of an approach where you kind of wrap the logger into your own method calls. Because then if you decide to change the logger, you're only editing here and here. You don't have to go throughout every place where you log a debug line or log a warning line and say, oh, this needs to happen here, or we need to change this here. No, you just change these guys right in there. And the final part is this mess right here. It's the setting of the privileges. Basically, we get the user ID and the group ID of something I've selected. For Mac, it's nobody. So basically, these are the variable signals, and I'm sure there is a better way of displaying that. But basically, this will be the effective groups and the effective user IDs. So when this program runs, it will run as if it was nobody. The kicker why this is important is that when you start up a script, the super user basically starts up the server. So basically, up until this line right here, root is running this program. That's a big problem if you get compromised, because now not only is your process compromised, but that process is running as the root user who has access to everything. And let's say we haven't done this, and we haven't done the whole change root thing, this line. So now you could have a user that has access, a super user access to your entire system. Or you could just have a dumb programmer who basically decided that, oh, before he starts on a certain process, he needs to delete out a certain directory. And then he misspells part of the variable so that what the OS gets passed is, please, rm -fr/*. And I blew away my entire server because I did not do this line, nor did I change the privileges. If I would have done either of those, the only thing I could have deleted is my subdirectory. And since in that subdirectory the user nobody has no privileges, it couldn't delete anything. But since my program didn't have this or that line, it had super user access to the entire OS. Goodbye, box. So again, yes?
What do you say GID twice?
Did what? That's a great question. I do not know. I don't remember, I should say.
Magic of how that sigil works.
Yes, so the question is, why is the group ID in here twice? And honestly, I would refer you back to, please tell me I have his book. I don't. Stein's book on networking. He explains it very in-depthly in there. I also go into it in my earlier talk of exactly why this is the format, but it is the format for these effective user and group IDs. And trust me, you can read a lot just about the difference in between actual and effective IDs. It's definitely a lot of black magic here, but the whole purpose of this black magic is to isolate you. You are trying to be a good neighbor. Again, you are trying to say this is my program that's running. I'm not an expert at security, but if I get hit, let just my little slice of the server get hit. If my program, if my Clash of Clans notification program gets hit, the only thing that they can ever affect is a subdirectory in my home directory as a user that doesn't even actually have permissions to that directory. So it makes it very hard for them to do anything malicious in that manner. So that's basically how we have programmed servers for years and years. And, you know, that's kind of, that is there, that was then, and this is kind of now. Now, instead of living on a hardware server, you live in a VM. In fact, you probably live just in a container or Docker. And we're just going to look, we're going to kind of focus on Docker because that's kind of the primary technology that's being used. So your program lives in Docker. And sometimes not even on Docker or in a container. Amazon has Lambdas, so you can basically say, here's my function. You run it however you seem fit. So basically, you can have code that's all by itself. It lives alone. And well, hell, if it lives alone, we really don't need to worry about it. So this was, all of this basically is to get my, run it to run here in the old way. And this is what I do in a container. I get everything that I need. I set my variables. I still initialize logging because I still need to log it somewhere other than the container because the container is ephemeral. And then I just run it. That's it. There's my while one. I commented out a lot of things. I'm trying to remember exactly why I commented that out. But this is the purpose. This is the exact same code. The run it section has not changed at all. It's everything around it. This is how we used to do it. And through the wonderful world of containers, this is all that we need to do now. Isn't that great? So why did I torment you guys through the first half of this presentation? Oh, sorry, go ahead.
Why are you no longer using a SQLite database?
Oh, I still am. The SQLite database is, this is the part that I commented out. I ran it, so it is right here, and I commented it out because I had commented, it is right here. By commenting this out, I ran into some issues. I was trying to debug them. This does actually kind of still work. It just doesn't actually send the SMS message. I'll fix that by the next meeting, which builds off of this one. Anyway, So I came across this wonderful Peter Pan quote: "Never say goodbye, because saying goodbye means going away, and going away means forgetting." And like everything on the internet, Peter Pan did not say this. It just sounds really cool. For the closest that I can come to, even though if you Google this, you will find it to Peter Pan, or the Peter Pan's author, I forgot his name, is in Hook. The Lost Boys say all of these words, kind of, and someone just put it together to make it sound much cooler. Anyway, we should not forget why we went through that pain in the old times. Basically, nowadays, we still live in a container. We live all by ourselves, which is sad. But we still need to be a good neighbor. Everything that we used to always do, we still need to do, and we still need to be very careful about doing. So, in that, the whole idea of what we used to do is you were containing yourself. You were restricting yourself to a slice of the server. Because if someone compromised you, you didn't want to be like me, who wrote this wonderful, and it really, once it started working, it was great. It stopped DOS attacks, in a wonderful fashion for a small hosting company. But, since I didn't do anything to, stay within what I needed, I first blew the entire server away. So if this would have been like in a commercial server, I would have blown everybody's stuff away, and that would have been very bad for me. Fortunately, I learned in a very safe environment. What do I mean with only use what you need? If you need to run Perl, use a Perl image. Don't run Ubuntu. If you have a Java jar, use the JDK image. Don't use Ubuntu again. If you have everything you need and everything runs just fine and you have a C compiler on the thing, delete the damn C compiler. Anything you leave behind, someone can effectively use against you. Nowadays, when you look at Docker files, and we will look at one shortly, everyone says, oh, you just need to do this and you're going to be up and running, you're going to be fine. And it's okay if someone hacks you, because if you get hacked, we're just going to turn off your container and we're going to spin you up again. It goes like that. And honestly, if you write your container properly, you can spin up new instances very quickly. But the beauty of that is that once someone discovers you have a big hole, and you restart yourself, well, they're just going to hit you again. They can hit you again many times. They might not be able to extract your data, but they could use your machine to do many things. So again, remove what you don't need. You don't need that C compiler. Well, don't install it in the first place, or delete it. Obviously, you can go really crazy on this. I would think as long as you go with selecting the right container, the right image to start from. In other words, you need Perl, you get a Perl image, instead of getting a full server OS. That's probably going to get 99% of what you need. If you're going to be really sensitive, you'll probably want to go through it with a fine-tooth comb, which really takes a lot of patience. Log in a persistent manner. Everything in the container is ephemeral. The idea of the Docker container is to basically start up, and it comes with initial state, and when it dies, everything dies with it. Whatever you write to it dies there. So it's very important, if you're going to log, you need to log outside of it. I'll show you that in a quick second. And use a user. Everyone says, oh, hey, Docker file from here, do this, do that, let's run. Hey, we're running as root. And if someone compromises your system, now they have root access. Now, it might be, if you've done everything else really well, it might be root access to, my Clash of Clans notifier, and they can spam me, which would suck. But it would only affect me. If I'm running it in a poorly designed, let's say I built it on Ubuntu, well, now they have a C compiler, their root, they can start up a web server, they can start, phishing, sending emails if they want to. They can compile their own email server and just, take me for a ride. So again, we want to be good stewards. We need to be very conscious of what we do. And in that, I'll go over kind of a little bit of the Docker file of a few things that can be done, if I can find my cursor. There we go. Sorry. So this is my Docker file. I built it off of Perl. I didn't build it off of Ubuntu. The only thing that should be on here is Perl. There's still a lot of stuff on there you got to be careful of, but at least I've taken some steps to try to minimize things. I've created a user, well, a group, and then a user. This user then creates a home directory named /app. These are things that I need to know where my Perl libraries are, and then I install the Perl modules that I need. Then I tell it, okay, from now on, we want to be the user COC app, and the working directory is /app. Now, one thing further I could do in here, and which I should have done in here, I could actually, in this container, I could say, okay, now change the root to /app. So the only thing you see is app. So if anybody compromises a server, the only thing that they have access to is the /app directory within a container, which is outside of everything. And then I get my my program in there, and then to run this, basically it just runs. And then I can have this up and running, and it'll run by itself. It's a little container. It runs only Perl. It's running my app. They would have to compromise this and then figure out how to do many, many other things before they could actually use this to do something thoroughly malicious. But one thing I've always understood is that hackers are much smarter than I am. So if there's a way, then there is definitely a way. Now, real quick, again, without getting too much into this, I did give a talk on Docker earlier this year. So if you need more information on this, I would, point you back to that talk. But basically, this is how you get away with your logging. So I create a volume. Oh, I'm sorry. That's the database that I need to get in there. Here we go. I create a volume to a log file that just happens to be in this subdirectory, which happens to be the directory where I wrote all this in. Next time I'll choose a shorter directory, I promise. And I put that to var log clashofclans.notifier.log. And in that way, when this runs, or I guess when this guy runs, and it writes to var log clashofclans.notifier.log, it actually writes to the log file that's on my host system. So when the container goes away, or it dies, or crashes, my logs are preserved outside of it, and I can understand why maybe. And again, if someone compromises it, hopefully there's some kind of logging to tell me what's going on that will survive this whole thing when it dies down. So this was just really a crash course of a couple of talks I've given in the past. So I hope that I've kind of covered everything. It's just the idea of, we used to go through all these steps to write a piece of software that would run forever, or run for a very long time. I think one thing I hope you'd notice that in the file here, I give it a sleep time. There's actually, for this type of code, there is absolutely, let's go over here where I haven't commented everything out. I sleep here. There's absolutely no reason to keep this sleeping. I could write this so that it only runs once, and then it reports out to some other external system and say, hey, execute me again in 5 hours. That way, I'm not even up for anything to happen. This program can wake up once, do what it needs to do, tell the host system, hey, wake me up again. So there are many different ways you can safeguard a server or something that's going to run for you without taking on all the responsibility of having something that is open and receiving requests 24/7 that can be basically taken advantage of at any point in time. So it's try to remember of what we always had to do, because now we don't have to do it again until someone really figures out how to hack containers. And try to be that good neighbor. We want to be that good neighbor with our coding. So finally, resources, great book. It's an old book from 2001, Networking Programming with Perl by Lincoln D. Stein. If you are going to actually do heavy server programming that can't be container restricted, great information there. Also, my Becoming a Daemon talk from 2011. But it really dives into this code a lot deeper. And earlier this year, I gave a talk about Docker, so if you need the Docker information, it's also there. So I hope you've enjoyed it. Any questions? Yes?
At the end, you showed that you're basically creating a shared volume, right?
Yeah.
Okay. So what about, there are other options, like anything that is shared could be hacked, no?
Yes, and yes, that's where, and the big thing here, so this is going to be a file that's just going to be read from, And this is going to be a file that's just a text file that's going to be written to. But you are right that these are then conduits into the host system. There are probably smarter ways of doing it. I don't know of any right now. But the main safeguard here is that whatever I write here, it's not going to be an executable. And whatever you can put into my database, well, actually, this program just reads from it. So if I did this properly, the user which gets into this database would only have read properties. So if someone were attacking the system, they couldn't inject anything into the database. But yes, you're right. Whenever you're creating a volume like this, you need to do it in a defensive manner. You need to make sure that this file isn't being scanned by the host operating system and executed. If it finds executable code, that it doesn't then try to execute it, which, obviously that's kind of a far-fetched scenario for this. But you are right. This is basically bridging the gap in between the container and the host operating system. So yes, when you do these, you want to do it in a very defensive manner. Good question. Anything else?
Have you used something like the Elk stack, which is Elasticsearch, Logstash, and
What's the
Kibana?
Kibana? Yeah, I have not. I do know people who have. The question was, have I ever used the Elk stack? I have not. So unfortunately, I can't talk to that.
So
If there's interest, I can.
There's also the Elk driver that you can send logs from your Docker containers.
Oh, right. Oh, yes. So, yeah, definitely. So with the Elk stack, yeah, we can do, there's basically a socket system where you can send data out and you don't have to have this direct volume in. Yeah, this is the lazy way of doing the logging. This was just the easiest way of doing that. If you are in a production system, you definitely want to look at definitely something like Elk or any of the logging type systems or Kafka. Flume, yeah, Flume, because those are you can send messages out to them and not worry about did they get arrived or oh I'm really busy right now, I don't need to worry about it. Like yeah, with this you could get definitely bogged down if writing to disk is slowing down right now. This could be potentially blocking if you have a very high volume server. So yeah, those are definitely good, and in fact preferred in a production setting, preferred alternatives. For my Clash of Clans notifier, this is totally fine because if someone attacks that, wow, someone has too much time on their hands. But yes, definitely.
Fluent D is the other one.
Fluent D.
Yeah.
Oh, okay. I've not used that one. Okay. Flume or Fluent D. Okay. Thank you. Great questions. Brandon?
No, I was scratching my
Oh,
head,
okay.
sorry.
Well, thank you for everyone for braving the weather tonight and coming out to see the talk on servers then and now. Have a good night. Enjoy some pizza. We have plenty. Bye.